Alright, so we're at 7.3, part 3 video. We're going to be giving bits and pieces of an ellipse, and we're going to have to come up with the equation. So just like we did with the parabola, we're going to want to draw a rough graph. So the center's at 0, 0. So no minus h, no minus k. We have a focus point at 3, 0, and vertex at 5, 0. So I graphed, here's 3, 0. Here's 5, 0. There's the center, but again, if I'm 3 to the right with the focus, I have to be 3 to the left. If I'm 5 to the right with the vertex, I have to be 5 to the left. So that tells me we have a horizontal ellipse. So when I write out my equation format, my a squared is going to be underneath the x squared because my vertices are going left and right, just like the x-axis. We're always going to use our Pythagorean theorem here with the minus sign, because what you're going to notice is that they predominantly give you the foci and the vertices. So we'll always have to find the b squared. So in this case, a is going to be a distance of 5, and the distance from 0 to 3 is 3 for the c value for the foci. So 5 squared minus b squared equals 3 squared, or 25 minus b squared equals 9. So all we have to do is solve this for b squared. So we'll subtract over the 9, add the b squared to the right. 25 minus 9 is 16. So I have my a squared, 25. I have my b squared, 16. There's the equation of my ellipse. Next, we have the foci at 0, comma, plus or minus 2, and a major axis of 8. So up and down 2, well, that means our center's at the origin, 0, 0. And that's your c value, so we know c is now a 2. But they didn't give us the vertices, but yet they still kind of did, because we know that the major axis is equal to 2a. So if the major axis is a distance of 8 units, set it equal to 2a, divide over the 2, a is equal to 4. So here we have a vertical ellipse. So your a squared has to be underneath the y squared, and a is that distance of 4. So again, you have the c, you have the a, you have to go find b squared using the Pythagorean theorem with the minus sign. So 4 squared will be 16, 2 squared will be 4. Subtract the 4 to the left, add the b squared to the right. 16 minus 4 is 12, that's my b squared. And my a squared again, that's the 16. So x squared over 12 plus y squared over 16 equals 1. Next, we have vertices at 7, comma, negative 2 and negative 3, comma, 2. Notice the y coordinates didn't change. And we have a focus at 4, negative 2. So again, plot these points. Negative 3, negative 2, 7, negative 2. Those are your vertices. And let's see. We know that the center has to be right in the middle of between these 2 points, so that's the midpoint. So the negative 2 is not going to change. So take negative 3, the x-coordinate, plus this x-coordinate, and add it together to get 4 and divide it by 2. We are at 2, negative 2 for the center. So 7 for that x-coordinate minus that 2 for an x-coordinate. That's 7 minus 2 is 5. That's the distance for A. Plot my foci, which is at 4, negative 2. All right, from the center to the foci, 4 minus 2 is 2. That's my c value. So because my vertices are going left and right, we now have a horizontal ellipse, and the equation is going to be such that the a squared has to be underneath now the x minus h binomial squared, with the b squared underneath the y minus k. Well, we found the center, 2, negative 2. So x minus 2, y minus a negative, well, that'll become y plus 2. And let's see, we can plug those in, and we can put in our a, which is 5 squared. That's going to be my 25 right there. We just have to go find b squared. So again, Pythagorean theorem, 25 minus b squared equals 4. Subtract over the 4, add over the b squared. 25 minus 4 is 21. That goes in the second fraction's denominator, and there's our equation. All right, next, vertices at 2, 5, 2, negative 1, and the c is 2. 2, 5, 2, negative 1. Again, now the x coordinates are the same, so take the y coordinates, add those together, divide by 2. Negative 1 plus 5 is 4 divided by 2. We are at 2, 2 for the center. So that's my h comma k. And from y coordinate of 2 up to y coordinate of 5, 5 minus 2 is 3. That's the a value. So a is 3, c is 2. We have a vertical ellipse, which means now your a squared is going to be located under the y minus k squared. Still use your Pythagorean theorem with the minus sign. We'll put all our numbers in. X minus 2, y minus 2, put in the 3 for a. So we have a 3 squared or 9 underneath the y minus 2. Let's go find b squared. 3 squared 9 minus b squared equals 2 squared, which is 4. Again, subtract over the 4, add over the b squared. If you notice, it's just like you interchange the 4 into b squared. B squared is 5. Put it into the denominator of the first fraction, and there's our equation. Last example, the center is at 1, 2. Well, there's your h and k. Focus is at 4, 2, and it contains the point 1, 3. So drawing my graph, there's the 1, 2. There's my focus at 4, 2. But then I have this point at 1, 3 directly above the center, so that has to be the covertex. And the c, focus to the center, 4 minus that 1 is a 3, so I now know the c value. But here's an example, since now we know that we're making basically perpendicular line segments here, that your b is going to be a distance of 1, 3 minus the 2 on those y coordinates. So we have foci going to the right, there should be a foci to the left, a vertex further right, a vertex further left. You have a horizontal ellipse, so your a squared is going to be underneath your x minus h squared. And now in this case, we're going to have to go find a squared. We're given c and b. Plug in our numbers, x minus 1 for that center right there in green, y minus 2, underneath the y binomial will be a distance of 1, that's your b squared. Plug it into the Pythagorean theorem with the minus sign. 9 on the right, a squared minus 1 equals 9. Add over the 1 makes it a 10. Put the 10 in for a squared, the 1 in for b squared. Technically, again, you don't need the 1, but if you did put it in there, it's perfectly acceptable. And that wraps up our part 3 of our ellipse.